Welcome to my lesson on tests for parallelograms. And in this lesson, we're basically going to take what we learned in the last lesson about properties of parallelograms, and we're going to use those ideas to prove when our quadrilateral is or is not a parallelogram, and also be able to do that if we need to on the coordinate plane when we're given a set of coordinates that represent a quadrilateral. Can we figure out, is it a parallelogram or not? So let's start out with some of our conditions for parallelograms. These you might recognize from our last lesson. These are basically the converse of the properties of parallelograms that we talked about in 6-2. If both pairs of opposite sides of a quadrilateral are congruent, that quadrilateral must be a parallelogram. If we have this condition, it must be a parallelogram. If both pairs of opposite angles are congruent to one another, here B and D are congruent and A is congruent to C, if you have that condition, then your quadrilateral must be a parallelogram. We also learned in 6-2 that in all parallelograms, the diagonals bisect each other. So if you have a quadrilateral where the diagonals bisect each other like this, you know that must be a parallelogram. And here's one new condition that we didn't talk about in 6-2. Here, if you had this information, where side AB was parallel to side CD, and it was also congruent, that would be enough without knowing anything about sides AD and BC. That would be enough to know that this is a parallelogram. You can picture if this side AB wasn't congruent to DC, let's say it was a little bit longer, the only way to achieve that is for this side DA to rotate out, something like that. And now you can see there's no way that if AB is longer or shorter than DC, there's no way for it to remain parallel, this side AD remain parallel to BC. So if all you have is one pair of opposite sides that are both parallel and congruent, that's enough to know that you have a parallelogram. Here, this condition in 6.9, can we prove that this is enough to know that we have a parallelogram? Well, if we go right back to our fundamental definition of a parallelogram, where we have a quadrilateral with opposite parallel sides, we could prove that if we draw a diagonal here. And immediately you'll probably recognize that we have two pairs, or a pair of congruent triangles by side, side, side. So side, side, side tells us that these two triangles are congruent. And if these triangles are congruent, then all of their corresponding parts are congruent, including their angles. So that means this angle over here is congruent to this angle over here. And it also means that this angle here is congruent to that angle there. When you have that condition, you can look at this and you can say, hold on, these are alternate interior angles. And if the alternate interior angles are congruent, then the lines that form them must be parallel to one another. And likewise here, these are alternate interior angles. They're on the interior of these lines and on alternate sides of this transversal BD, and they're congruent. And when the alternate interior angles are congruent, then the lines that form them must be parallel. Okay, let's take a look at a couple of examples. Could we determine whether this quadrilateral is a parallelogram? Justify your answer. Does this meet any of the conditions that we looked at in our tests for parallelograms? When you see this problem, hopefully you're inclined to go ahead and mark some of the things that you see. These sides have equal measure, they're congruent. These sides have equal measure, they're congruent. And hopefully you recognize that condition looks a lot like what we talked about in 6.9. So yes, that is a parallelogram. We have both pairs of opposite sides congruent. Which method would prove this quadrilateral is a parallelogram? Hopefully this looks familiar to you. We have a pair of opposite sides that are parallel Since they have the same measure, I'm going to go ahead and mark them congruent as well. Hopefully you recognize that as matching this condition in 6.12 that we talked about, where we have one pair of opposite sides that are both parallel and congruent. If you have that, you know you have a parallelogram. All right, let's take a look at a word problem. Here we have a car jack. And in this diagram, they're telling us that AD is congruent to BC. So AD is congruent to BC, I'll mark that. And AB is congruent to DC, I'll mark that. Based on this information, which statement will be true regardless of the height of the jack? Now you can picture, if we turn this crank at D, the car can go up and come down. So these angles are going to change. But what won't change, or what will always be true, regardless of that height? Will angle A always be congruent to angle B? Well, here's angle A, and here's angle B. These are consecutive interior angles. They're not opposite angles. And one thing we know about parallelograms, first of all, do we recognize that we have this condition right here? We have a parallelogram. ABCD is definitely a parallelogram. And in parallelograms, we know that the opposite angles will always be congruent. So angle A is going to be congruent to angle C, not to B. Okay? So this guy's no good. Will angle A always be congruent to angle C? Well, these are opposite angles in a parallelogram, so yes, that's going to be true. If you're not in the habit of reading the remaining examples when you take a multiple choice test, you should get in that habit. It's a good strategy just to make sure you didn't make any mistakes. Will AB be congruent to BC here? Well, no, that is not necessarily true depending on the construction of this jack. Only if this jack was built as a rhombus, which we'll learn about later in this chapter, that actually be true. So that's no good. And the measure of angle A plus the measure of angle C will always equal 180. That's not true. The measure of angle A plus the measure of angle B will always equal 180 because those are consecutive interior angles. So this is not going to be true. But angle A will always be congruent to angle C regardless of the height of that jack. All right, let's try one with some algebra in it. Here. Could we find x and y so that the quadrilateral is a parallelogram? If this is going to be a parallelogram, you should go ahead and mark the things that you know are going to have to be true. Okay. Now we could mark things about the angles as well, but these expressions all represent sides of the parallelogram. So I'm just going to mark that for now. So hopefully you see this equation here. If these sides are congruent, then these expressions must be equal to one another. Okay, how can we solve that for y? Don't forget to distribute. Distributive property, we spent a lot of time on that last year in Algebra 1. Get 3y plus 3 equals 4y minus 2. What would we do next to solve for y? Subtract 3y from both sides. And if you want to, you can add 2 to both sides at the same time. You get 5 equals y. Good. And can we find x? If these two sides are congruent, then they must have equal measure. That means these expressions must be equal to one another. So we should get 4x minus 1 equals 3 times the quantity x plus 2. Go ahead and distribute that 3 in order to solve this. And we're going to get 4x minus 1 equals 3x plus 6. By the way, if you're not in the habit of pausing the video anytime that you want to stop and solve something before I solve it, it's a really good habit to get into. Pause the video, take a crack at it yourself, and then see if you get the right answer. Here we can subtract 3x from both sides. Well, we add 1 to both sides, and we get 4x minus 3x is x, and 6 plus 1 is 7. These, of course, cancel. Okay, so we get x equals 7. Always go back and read the question again. Did we do what they asked for? They wanted us to find x and y. We found x equals 7 and y equals 5. Okay, let's try another one like that. Here, could we find m so that the quadrilateral is a parallelogram? Well, what do we know if this is going to be a parallelogram? Those sides are going to have to be congruent, are they not? And from that, we should be able to find this equation. These sides are congruent, they have equal measure. These expressions, therefore, must be equal to one another. And can we solve that for m? What would you do? Subtract 3m from both sides. And subtract 2 from both sides at the same time. We'll get 6 equals m. Okay? All right. Let's take a quick summary. Look at a quick summary of ways that we can prove that a quadrilateral is a parallelogram using the tests that we've learned. 1, if you can show that both pairs of opposite sides are parallel, well, that is our very first definition of a parallelogram that we've looked at. So if you know that's true, you have proven you have a parallelogram. If your quadrilateral you can show that both pairs of opposite sides are congruent, then that is enough information to prove that you have a parallelogram. That is this condition right here. If you can show that both pairs of opposite angles are congruent, that meets this condition right here. If you know that, that's enough information to prove that you have a parallelogram. And if you can show that the diagonals bisect each other, that's this condition here. If your quadrilateral has diagonals that bisect each other, it's got to be a parallelogram. And lastly, we have this new one that we looked at today, showing that a pair of opposite sides is both parallel and congruent is enough to prove that your quadrilateral is a parallelogram. All right, with all of that, can we take a look at the coordinate plane here and see if we can determine whether this quadrilateral is a parallelogram. Quadrilateral QRST, they give us these coordinates. We can plot them. Okay. And could we justify our answer by using the slope formula? Okay, how would we use the slope formula to prove or disprove that this is a parallelogram? Hopefully you remember slope is rise over run. Sometimes we say it's delta y over delta x. And sometimes we say it's y2 minus y1 over x2 minus x1. Those are all different ways of finding slope. When I've got them graphed, I like to look at rise over run or delta y over delta x. It's very easy to pick out. Let's go ahead and take a look at TS and QR. If we knew that TS and QR had equal slopes, well, by definition, we would know that those lines must be parallel. So let's take a look at our going from T to S. What is our rise? We go down 2 and over 4. Okay, so that's my slope, negative 2 over 4, down 2 over 4. So that's a slope of negative 1/2. Let's take a look at QR and see if we have the same slope. If we don't have the same slope, we can immediately say this is not a parallelogram, and we're done. However, it looks familiar here. Going from Q to R, my slope, I go down 2 over 4. That's negative 1/2. If I know these two have the same slope, I'm just going to go ahead and mark them. Those are parallel. Okay. Now, it's not necessarily a parallelogram, though, just based on that information. I have to have two pairs of sides that are parallel. Both pairs of opposite sides have to be parallel. So let's take a look at the slope going from T to Q. Here, my rise over my run, I go up 4 over 1. And so that is a slope of 4 over 1, or a slope of 4. When I go from S to R, I go up 4 and over 1. So that also has a slope of 4. So I can see here, I'm going to go ahead and mark these sides parallel as well. And when I have that condition, I recognize that that meets this first definition here, showing that both pairs of opposite sides are parallel. Boom, we have a parallelogram. Let's try one more that we have to graph. This time, they're not giving us the picture. We have to graph it. Why don't we go ahead and see if we can figure out whether EFGH is a parallelogram. Let's go ahead and draw ourselves a coordinate plane here. I'm going to call this my y-axis. Okay. And I'm going to make an x-axis here. It's right down the middle. There's my x-axis. Let's plot these points. E is at -2, 2. Okay, there's my x-axis. -2, 2. Here's point E. Okay. And F is at 2, 0. F is right here. 2, 0. Good. And G is at 1, -5. 1, 2, 3, 4, 5. There's G at 1, -5. And H is at -3, -2, right here. Okay, there's H. -3, -2. Okay. And I'm going to just go ahead and draw. If you want to use a straight edge on this, you can. You don't have to. I'm just going to go ahead and draw the 4 sides of this quadrilateral. If you've got a sharp eye, you might be looking at this and saying, something doesn't look quite right. And I'm looking right now at HG and EF, and I'm suspecting that maybe they're not parallel. If they're not parallel, then I don't have to check anything else. So I'm going to go straight for those first. I'm going to look at the slope from H to G. I go down 3 and over 4. So this has a slope of -3/4. Let's check and see what the slope of the opposite side, EF, is. Going from E to F, I go down 2 and over 4. So this is -2/4 or -1/2. Those are not parallel. If those aren't parallel, I don't need to check anything else. I know this is not a parallelogram. All right, that is my lesson on tests for parallelograms. I hope you found that helpful. Good luck on the homework, and don't forget to smash that like button. Thanks, guys.